Okay, ladies and gentlemen, when we look at section 5.5, this is a continuation of factoring, but there are two special types of factoring that come up in this section. One type is something you should recall, referred to as the difference of two perfect squares. A plus b times a minus b, when you FOIL it out, we get a squared minus ab plus ab minus b squared, so the middle terms drop out, and we're left with a squared minus b squared. This formula is referred to sometimes as the difference, because of subtraction, of two perfect squares. That's a good name to know. You're going to be using it soon. A plus b quantity squared means a plus b times a plus b. FOILing it out, that would become a squared plus ab plus b squared. When I collect the two middle terms, it becomes 2ab. This trinomial, a squared plus 2ab plus b squared, started off as a perfect square. Notice it was something times the same thing, which is why this is sometimes called a perfect square trinomial. Now, let's look at the next page. You're asked to factor completely. 25 minus y squared. 25 is a perfect square, 5 times 5. Y squared is a perfect square, y times y, so this perfectly fits our difference of squares formula. 5 plus y times the quantity 5 minus y. It doesn't matter whether the plus or minus comes first, just as long as they alternate. Go directly underneath. 9x squared minus 4y squared. The minus means it's the difference. 9x squared is a perfect square, 3x times 3x. 4y squared is a perfect square, 2y times 2y. This fits the difference of perfect squares. 3x plus 2y times the quantity 3x minus 2y. This next one is a little tricky. Notice this is a perfect square and this is a perfect square. However, in the middle we have a plus sign. That's always going to turn out to be prime. Some people think the answer to this is 3z plus 8 times 3z plus 8. But if you actually try that out on your paper, you would find that you would come up with a middle term that's not here. So what you need to remember, the difference of two perfect squares is going to factor. The sum of two perfect squares is going to be prime, meaning the only way to factor it is itself times 1. Okay, x to the fourth minus 16. This starts as the x to the fourth is a perfect square because it's x squared times x squared. 16 is a perfect square, 4 times 4. This is the difference of two perfect squares. One's a plus and one's a minus. But notice where I'm pointing, we're not done, because x squared minus 4 is the difference of two perfect squares again. In fact, that breaks into x plus 2 times x minus 2. Notice that the x squared plus 4 stays the same. Remember what we just talked about, when it's a plus in the middle, you can't break it down anymore. That's what prime means. And my last example for this video, 100x cubed minus x. The first step is to take out the GCF, which is an x. In parens, that leaves me with 100x squared minus 1. We're not done. 100x squared is a perfect square. 10x times 10x. 1 is a perfect square. 1 times 1. And the minus makes it the difference of two perfect squares. So this breaks down as 10x plus 1 times 10x minus 1. And don't forget to put that x in front, because what you took out as the GCF is definitely a factor in your final answer. So don't forget about that. Okay.